Welcome to this episode of the Structural Engineering Channel, a podcast focused on helping structural engineering professionals stay up to date on technical trends in the field and to help them succeed in their careers and lives. In this episode, Rachel and I will be talking with Mark Robertson, a project manager at Wicke, Herfst, Maver, or WHM, about structural engineering, mass timber projects, and the future of this building material. We'll also discuss some of the challenges and opportunities of using mass timber in construction, and Mark will share his insights on how to make mass timber projects more cost-effective and sustainable. I'm your co-host, Matt Picardle.
And I'm your co-host, Rachel Holland. So let's jump into the conversation this week.
Hey, Mark, thanks for coming on. Again, appreciate you coming on and talking about mass timber with us. Could you give our listeners a brief overview of what you do on a daily basis and how you got into the world of structural engineering and mass timber?
So I'm a structural consultant in buildings, so I don't touch bridges or any vehicle traffic structures. It's all buildings, mainly residential, commercial buildings, schools, things like that. I got into timber quite early on because I was at school, had a pretty good prof for timber, and I got a scholarship, an industrial scholarship with a company. So an industrial scholarship is the school or the government pays part of the scholarship and the other part gets paid by the industry. And in this case, I partnered up with a company called Structure Craft. They are kind of a specialist in unique heavy timber building construction. They did the Richmond Speed Skating Oval. I did that with them. And my research was for a project that they did in Washington, D.C., which was a project involved 3 existing performing arts theaters. And they put this 50-foot tall, curved, slanted glass facade around that was supported by a wood structure. And my research was on how that structure works and testing the connections for it at UBC. So I did, I did analytical models and also physical testing. And I was in the shop at UBC at night, grinding stuff for welds, and actually making the specimens was a lot of work. But it was also a lot of fun. So I did that, and that kind of got me in the door with Structure Craft, and they were at that time related to Fast and Ep, which is a consulting firm, also structural, and those two were linked together. So I got in with that firm. I worked there for a number of years, and funnily enough, that was the first project I worked with them on. Was that what I did the research for? And as I was leaving, that was the last project for me to work on. It was finishing off. So it's kind of a full circle thing.
So
anyway, so
curious about that scholarship that you mentioned. It sounds pretty intense. And is that like an undergrad thing, or was that graduate school?
Oh, that was graduate school. Yeah.
Okay. That makes more sense.
Yeah. Sorry, I should have mentioned. So that was it was a master's of applied science postgraduate degree.
Awesome. Okay, so we're mass timber has kind of gotten like all this, it's been kind of like all the rage lately. We have a lot of listeners that are like newer engineers or sort of fresh out of school. Do you want to go ahead and just like give them sort of a background on what it is and maybe like in your opinion why it's becoming so popular in terms of like a construction material?
Yeah, so I think the key to mass timber is the development of the product called CLT, which is basically a simple way to think about it is it's jumbo plywood. So it's plywood are sheets that are about 3/4 to an inch thick. Sometimes CLT, you're getting up to 4 to even 10 inches thick panels, and it's made by gluing 2x4s together but crossing them in different directions. So it makes for a very stable panel that can be dropped into place, and that forms your floor. The key to that is fire resistance. So traditionally, like light wood frame, when you want to make a fire, you want to use small elements that will catch fire. if you put a big log on the fire and try and light it, you'll never get it lit. It won't burn. So that's kind of how mass timber works. Like if there is a fire in the building, they've done experiments. They've seen the fire put itself out and not burn right the way through the mass timber. So there is a resistance of these larger sections of wood to fire. So what that's unlocked is, historically wood is prohibited in buildings and cities of certain sizes, or for certain uses like commercial, for schools, because of that fire issue. But when mass timber and CLT came into the market, and the research about the fire properties became apparent, now these buildings can be made out of wood, which is really exciting for the construction industry, and also for global warming, because you can avoid using carbon intensive materials like concrete, and replace it with wood on these bigger buildings.
I didn't realize that
that's
was one of the reasons that it kind of caught traction, was because of that. I didn't realize that, but it makes sense.
Yeah, so it seemed like with the fire, I think the general public would be, should we be building things out of wood if they're going to catch on fire? But with with mass timber, it seems like the way they get around that in terms of the fires is like your analogy of putting a huge log on a campfire. It's not going to burn, and if it does, it seems like they're big and chunky enough that they meet the fire rating requirements of the building code, since they're allowed to do that now. So yeah, I think that's like something in terms of, when the public brings it up, because I'm pretty sure they'd bring it up. It's like, okay, we got these tests and this is how it works. Like you were saying, it makes that char layer, that sacrificial char layer. I've seen some photos. So
yeah,
it
exactly.
like that's
so technically it
starts
to burn, and the char forms on the outside, and that char, the material that char is acts like an insulation, so it keeps the inner part of the wood cooler and prevents further burning.
And you also mentioned sustainability, in terms of, I know sustainability, there's a lot of, especially in the US at least, there's a lot of firms committing to the more sustainability. I think it was the 2030 Act, where we're going to reduce our carbon footprints in the structural engineering industry. How does mass timber contribute to that aspect?
Yeah, so I don't know if the general public understands this fully, but wood, like in the forest, the trees, eventually they're gonna die. The trees are gonna fall down. When they start decaying, they release their carbon back into the atmosphere, and so that's adding to the carbon in the atmosphere. By harvesting the trees and building mass timber products, we can lock in that carbon into our buildings and prevent it from going up into the atmosphere. We're also offsetting more carbon intensive products like concrete or steel by using wood instead of those materials. So there's that as well, which is a benefit. So yeah, using mass timbers is very effective in reducing carbon in buildings.
When you in your bio, we were reading that you teach some courses at a couple of institutions, and I was curious, what are some of the key like principles or techniques that you emphasize when you're educating like the next set of engineers, and how much of that is, I mean, obviously you have to teach the whole structural, like, like safety in terms of like it doing what it needs to do in terms of like the building, but like how much of it, I feel like most people I know that are young these days, they're really focused on sustainability. So like how much of it that you teach do you focus on that versus like the structural aspect?
Yeah, so I guess what's the phrase for that? You have to walk before you can run. So you have to learn basically the fundamentals first of statics and how. So that's quite involved teaching that. So that's really the focus in school, is learning, you know, how to make buildings stand up. And then once you kind of in the higher level grades or levels at school, that's when you can start talking about choosing materials that are sustainable and approaches for that. I don't know, when I was going through school, certainly there wasn't very much focus on that in school.
Same.
Yeah.
Yeah.
Which is
So
pretty
are
common.
you teaching? Oh, sorry. Go ahead.
No, I was just agreeing.
You
It's
didn't
not
have a
taught
lot
a
of
lot.
sustainability either, Matt, in your
No, not.
education?
It was mainly about statics, and at least in my school, we had some design classes. But I know some courses are really theoretical as well in most schools.
Yeah. So in the courses that you teach, Mark, are you more focused on like the structural stuff? Is that where your area kind of lies?
Yeah, it's pretty
Okay.
much. And I mean, people, so I teach two different scenarios. One is I teach like an introductory structural design course at BCIT. That's really the walking before you can run course. And then I also teach part-time. It's through the Structural Engineers Association of BC. They put on like a series of courses for practicing engineers. So those are the courses where you're running. And so the course I teach it actually with a couple of other consultants that we team up and teach that course. But it's introduction to heavy timber construction and design. Now, I'd say most people going to the course already kind of they're going there because they understand the sustainability issues and that wood is sustainable. There's nothing really we can teach there other than use wood in your projects.
So when you're teaching those courses to the SEABC, and you're talking about mass timber,
Yeah.
What are a few of the principles and things like that you really focus on with those other consultants that are running?
Yeah, I mean, so the course is open to people who don't have much experience with wood. So we really want to start with the basics of the material of wood and how it behaves. So focusing on its properties, its strengths, its weaknesses. You know, it's an organic material, so in certain directions it's very strong, perpendicular to the grain, it's very squishy. It's also prone to shrinking and swelling when exposed to moisture. So you have to think about that in your detailing of the structures. So we go through all that in the course.
Okay, super interesting.
Yeah, and you mentioned that Olympic Oval in Richmond, BC, and I know you've also worked on the Virtuoso. I think that was the first private multifamily residential building using CLT in Canada. Can you share some of what were some of the challenges and some of the insights you learned from those projects? I know they're pretty big projects or unique projects. So I'm sure there were a lot of challenges.
Yeah, so the Richmond Oval was a very unique project. I don't know if I'll see another one quite like that again. But my involvement was mainly with there were these panels that were made from, at the time, pine beetle infestation was really a big in the news. There were a lot of trees dying, and so they were wanting to harvest pine beetle wood in particular. And there were these panels that are basically constructed from pine beetle 2x4 wood, and they're spanning for 40 feet. So to get you're not going to span 40 feet with a 2x4 typically. So what we did was we kind of spliced them together in this arch, which was a very unique shape, and it ended up having some acoustical benefits as well. But it was essentially a tied arch with a tie rod, and this was fabricated by Structure Craft. And it was very much a research and design, accelerated research and design process where we design, we test, things would fail, learn from it, redesign, test, and then move forward once it was showing that it was working well. So that was a very interesting project in that sense, very innovative. talking about Virtuoso, that was I think the largest scale that I've used CLT with before. We've done some work with CLT, but not very much on that scale. Structure Lam is a CLT supplier, and they had it was fairly new product for them, and so we got the latest information from them with the layups and the properties of the CLT panels that they had, and we had to do quite a bit of background research on vibration and making sure that works. In terms of that project, it was all encapsulated, so there's no exposed wood. So in terms of like fire protection, it was not any different than any other light wood frame building. It just had that benefit of CLT. And personally, it was a bit of a learning curve for myself, because my first time, or one of my first buildings, that was a 6-story light wood frame as well. So Virtuoso is essentially a 6-story residential building where the walls were stud frame, and the floors, instead of regular I-joists, we replaced it with CLT panels. And that was just to accelerate the construction, which it did. It went in quite quickly.
So just the floor systems and then everything else stud framed.
Yeah.
Okay. Interesting.
Yeah, I know for our listeners that don't know what these buildings are, I mean, they're big enough where you can just Google it, and I think they're worth the Google. I know, like for the oval Olympic one, it looks pretty cool. It's when I see some pictures of it, you can imagine a stadium that's essentially has CLT or mass timber as the arches, as the roof. How big is that span? Do you remember? Because that span is massive.
Oh yeah, so I was talking about the panel spanning 40 feet, so that's between two major arches.
Yeah.
And I believe those were 300 feet span. Yeah, they're
out of
huge.
wood.
Yeah.
Crazy.
Yeah.
Yeah, and the
Yeah.
Virtuoso one, that's pretty cool too. It's with the unique. I know something that you couldn't do with typical conventional light frame wood is like you were mentioning, it was really curvy, and yeah, that makes sense if you go with CLT, because that framing would be a pain if you're trying to do that out of a light frame. So that's pretty cool.
Both of those obviously like pretty innovative or cutting edge ways of building. What else have you seen emerge in terms of like, you know, just in our field in structural engineering, you know, mass timber construction specifically? What technologies or other things have you seen kind of come about?
There's a variety of other mass timber products that I don't know if they've got the same popularity as CLT, or they're maybe in their infancy a little bit, but there's products like Fine Line, which is more like, it's constructed more like plywood, but to a higher quality and also much thicker. So it's much thinner laminations of wood to build up these large sections,
So
as opposed to using 2x4s.
give us some examples, like instead of 2x4s, like how thin are they, and then how thick are they?
Yeah, so the laminations would be a couple millimeters thick, like an eighth of an inch roughly.
And how
so
thick will they get overall?
Oh, and they'll build them up into, you know, similar to CLT. They'll be 4 to anywhere to 10 inches thick. Yeah, so that they also call it MPP, mass plywood panel, I think, something like that. And there's also another product coming on, which is a micro CLT, which is somewhere in between the two. It's got like 3/4 inch or 3/8 of an inch thick boards, so they're just a lot thinner to build up the sections with. And there's some interesting things you can do, like with those panels, and also people are getting into curving them, so you could get a curved CLT almost. So that should be interesting.
Awesome.
The other thing that's really exploded is the development with screws, which most people, I'm not sure many people know about. To engineers, it's very useful. There's companies, you know, producing really high strength screws. They can come like in lengths of, I think the supplier showed us one that was like 3 feet long.
Yeah.
Yeah,
Simpson's
so
definitely expanded on the screws in
yeah,
that department, and it's crazy. Like at workshops and stuff, you hold up some of those screws and people are like, that's a screw? Like, that's crazy.
Yeah. And with those screws, some of these suppliers are producing technical papers on how to use them, which is really well received by the industry. So things like if you notch a beam, you can now, instead of saying, oh no, that beam it isn't going to work if it's notched like that, it's going to split. You can put screws in and reinforce it, kind of like you reinforce concrete with rebar. You can do the same thing with these screws into wood, which is, so it takes care of some of the weaknesses of wood, like tension perpendicular to grain is a weak property of wood, and you can reinforce it with these screws.
Awesome.
And yeah, it's a 3-foot screw. That's a weapon.
Yeah. You don't want to upset the contractor when you go to site and they have those.
You're like, your install is perfect. Moving along.
Inspection passed. Yep. Yeah. And since it is becoming more popular for new structural engineers, they're probably going to get put on it, and they probably didn't take mass timber classes in school. What are some of the major differences in terms of for a first-time engineer, like that they might miss, or common mistakes that they should look out for when they're in their first mass timber project?
I think I mentioned understanding the material properties. So if you were to just have a column and sit the CLT on top of it and then land another column on top and go 12 stories tall, you're going to squish that CLT because it's perpendicular to grain. So you need to really understand the properties of that wood and design another way to avoid loading the CLT in the wrong way. Also thinking about shrinkage. So like details that don't, unnecessarily restrict the shrinkage, allow it to happen, so that something doesn't start splitting when it tries to shrink.
Yeah, those are good points. I know the shrinkage for when I first started off, seeing some examples of typical connections that's something that, I remember as a new engineer I didn't think about. I was like, oh, it does matter how you place those bolted connections. So yeah, thanks for bringing me back to my memories.
Yeah, with wood, more is not necessarily better. Like filling it with a whole bunch of bolts, that could be a bad idea.
What about so yeah, being aware of like the wood properties, right, and how to make it work for that material. What about in terms of like the cost effectiveness, right? So if you're building with mass timber, how do you balance like the cost effectiveness versus still having it be meeting all the safety and durability and everything that you need with a structure? How do you, what's your advice on that?
Yeah, so the cost effectiveness of mass timber is directly proportional to the volume of wood fiber that is going into these products. So, and the majority of the volume of wood comes from the panels themselves. So if you can do whatever you can to get those panels as thin as you can comfortably, that's what you should do. There's plenty of span tables for CLT, but I recommend making sure you really understand what's behind those and knowing when you can push a little bit further to make, so say you're not quite able to get a 5-ply panel to work. Do a little bit of research, see if you can get it to work with first principles and designing it. Because those span, like for an example, the span tables assume 2-span continuous. Sometimes I can push the spans a little bit further by making them 3-span continuous, and it can help a little bit with the vibration. So things like that, if you're just on the edge, try and make it work as much as you can. Don't just stop at the catalog and say, oh no, we got to go up to a 7-ply panel.
So do you find that you end up actually like calcing all of these more often than actually like using the tables that are provided?
No, I definitely use the tables more often. It's just in
Okay,
those certain
when
like
you're close.
yeah, when you're close and that it's that one-off location in the building that's going to drive everything, then
Right.
that's when you really want to spend a little more time on it.
Excellent.
Try and get it to work.
And Mark, what do you see for as the future of the mass timber in the construction industry? Maybe in the next, I don't know, 25 years, do you see any trends or developments that engineers and contractors should be aware of?
I pretty sure we're going to see taller buildings as we move forward. We're approved to go to 12 stories, and we're going to see. I'm hoping we're going to see a lot more of those buildings go up in the next few years, and there will always be people that are able to push it taller with going outside of the building code, but those will be a little less common. But I think what's going to be exciting is to see a lot more of these buildings take away the concrete buildings and replace them with wood buildings, especially in residential.
Yeah. And it's still like, when you say kind of go beyond the code, I mean, that's still it's still relatively, I can't talk. It's still relatively new in the code, right? So it's still,
Yeah.
I mean, everything in the code is always being like revised and, moved forward or whatever. But I mean, this area still has a lot it's going to grow a lot still, like in terms of the code.
Absolutely. Yeah.
So, yeah. Okay. So what about if, some of the listeners that we have, if they wanted to learn a little bit more, I know I just took an AWC CEU thing online for talking about the fire resistance for mass timber. But besides that, like if you were to have any suggestions for additional resources or educational opportunities, what would you recommend for people that are looking to learn more about this and maybe get a little bit more involved?
I guess so. Is this what sort of person are we talking about? Like a structural engineer or architect
I mean,
or
I would say structural engineer. I think that's most of our listeners.
okay. Yeah. Okay. Yeah. There's definitely a lot of good design guides out there. There's well in Canada and Vancouver, there's Foreign Tech has got a bunch of publications on the mass timber. There's a mass timber design guide produced by the CLT suppliers. Structure Lam has a few brochures as well. There's also, I mentioned the SCABC courses, but that's very specific to Vancouver. So, I would just look, there's probably equivalents to those courses in other parts of in both the US and Canada and other provinces and states. So I'd be looking out for those. There's also the screw suppliers. Those I mentioned, those technical guides, those are extremely valuable. And they can enable you to do a lot of things with wood by using those screws.
And then just because you did mention it, like, do you have other suggestions for an architect or something like that? Or were you just making sure that we were talking about structural engineering?
Yeah, I just wanted to make sure I was online with what you were looking for there.
Okay.
And I just had a follow-up for that. So I know for students, especially if they're new, I think I've seen some where they struggle with maybe some of the 3D visualization stuff. And I don't know if you've seen any resources, but are there any like I don't know like drawing plans or 3D models that students can look at? Because I know I think AISC does it for like the Steel Institute. They have like sample buildings. I just figured that'd be really helpful to like if because we can just because a lot of the time students they don't know, so we can just show them like, hey, here's how everything comes together. And here are the parts. Here's that CLT panel. You can actually see it. And then they can go look at some plans because a lot of the times they have a lot of trouble, even figuring out what plans are.
Yeah, I mean,
I don't know if we have that yet.
I don't know if we have that kind of thing established yet because it's very, there's a lot of development happening. But like seeing presentations from consultants and architects, I can't believe I didn't mention it, but like the wood conferences, definitely go to those. Like there's the one in Oregon every year. Mass Timber Conference there. That's worth seeing. You can see them present the building. They'll show you drawings usually in those presentations. So you can actually visualize the drawing and relate it to the real thing because they've got photos as well. So those you can learn a large amount from. We've got Woodworks here in Canada that puts on conferences. So those are great.
Awesome. Thanks for all those
Yeah.
resources.
All right. I don't have any other follow-up questions. I don't know if you do, Matt, but
No, I think that was great. Yeah, thanks so much, Mark, for joining us and answering our questions. Yeah, really great to talk to you today.
yeah, thanks.
Yeah, you too. All right, thanks.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and or questions. To leave them, please visit the structuralengineeringchannel.com. There you'll find a summary of the key points discussed in today's episode, as well as any links to any of the resources or websites that we mentioned. Don't forget to subscribe to Apple Podcasts, Spotify, or wherever you listen to your podcasts. Until next time, we wish you the best in all of your structural engineering endeavors.